Hello all, welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, write a Java program to demonstrate linear search. Let me answer this question with practical demonstration. Before we move to the practical demonstration, first you need to understand what is meant by linear search. There are different type of algorithms we have in Java: linear search, binary search, hash search, like that. Linear search is one of them and is the simplest one. Very simple, guys. Okay. So linear search is also known as sequential search. Okay. It's also known as sequential search. Let's assume that. Okay. I'll give one real-time example. Okay. So there are 10 people here, guys. Okay. There are 10 people. Okay. There are 10 people. Let's say in a police station, let's assume that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people are there. Okay. So some robbery happened at your house. Okay. Some thief has, okay, stole some items from your house. Some thief has come to your house and stolen. And at that time, you, you try to catch the thief, but unfortunately, thief has, got left your house. You're unable to catch him or something. Okay. Then as you are a person, right, you have remember his face. Okay, thief's face you remember. Okay, so now you went to the police station to complain, and after a few days police people have called you that they have, these 10 people, okay, they brought, and you have to identify them. So in case of sequential search, what you will do, you will start with the first person. Okay, is the face that you have seen of the thief is matching with this person or not? No. Fine. Then you'll go and go to the next one in the line. Okay. You'll not, this very simple algorithm, guys. One by one, you'll check and rule out. Sometime what happens is, okay, maybe this person is a thief. Let's say it got identified, face got matched. Like this, you will find the item. Okay. Searching, you are searching for the thief in this particular 10 number of thieves. Okay. 10 number of people who are suspects. Okay. So in this 10 suspects, who is the thief? You have to find it out. So for that, since you identified the face of the thieves, you have to go here to the police station when they call, and you have to go and see the face of each and every thief in a sequential order until you find the thief's face who has really stolen from your house. Okay, this is what is sequential search or linear search, guys. But what if you have to apply this sequential search in a different situation? You went to a cricket stadium. Let's assume that you went to a cricket stadium. So there in the cricket stadium, a lot of people are there. Okay, thousands of people are there, guys. Thousands of people are there. Okay, the people are like anything, and in this people, one of the person is a thief. Let's assume that one of the person is a thief. That particular thief has stolen your purse. Okay, now tell me, can you do if you follow this linear search algorithm where you have to you just remember the face of the thief. Okay, you start from here. Okay, the face is not matching. Then you will go here. Is it suitable? Is a linear search algorithm suitable here to find the thief when there are more people at the stadium? If there are only 10 people in the police station, you are able to find it by applying the linear search one by one. You are going here. For this, you will not go with the linear search algorithm, guys. You will be rush. You see, in this case, right, you will not be checking one by one face. You will directly move like this. Okay, directly move like this or like this. You will try to cover this number of people in a faster way so that you can catch the thief fastly. But you cannot go one by one. That will not work. It will take a lot of time. Okay, there will be a lot of time. By the time the thief will escape, the thief will escape also. Okay, so you see, linear search algorithm for finding the required element in the list of items, okay, is less, then we can simply use a linear search or sequential search, the alternative name we can use for searching the particular item from the collection. If not, okay, if the items are very big, the linear search algorithm will take a lot of time, guys. Then it is not suitable for finding the required item from the list of items, okay, collection of items. Okay, if the list is very big, then you will not be able to use linear search in that case. Okay, linear search, also known as sequential search, simple searching algorithm that checks each element in collection. Collection can be an array list, anything, one by one until the target element is found or the entire collection has been searched. Okay, you have to either find the person or find the element, or you have to complete searching for all the things in the collection. Okay, it's slow compared to the other searching mechanisms. Okay, it's slow when compared to the other searching mechanism. It's kind of very slow, guys. It's kind of slow compared to the other searching mechanisms. Okay, so and it is only recommended to use. Okay, if you are using this sequential linear simple searching mechanism algorithm with a large list of items, right, it will be slow, and you'll get the results very late. Okay, so it's better you generally go with the linear search when the list of items in the collection, that is array or array list or any other, okay, hash set, hash map, anything, when you're searching in that collection, right? Okay, if the collection items are less in number, then you can go with the linear search. This is a theoretical part, guys. Okay, slow compared to other searching mechanisms and suitable for the less number of elements available in the collection, means you generally apply this linear search for finding the required element in the list. Okay, so it can be an array, a collection or list. Here is an array list or collection, whatever it maybe you can call. Okay, so I'll demonstrate with the different examples. I'll use arrays here. Okay, and we'll do that searching operation. Okay, so for that I'll switch to this Eclipse ID and create a new class, guys. I'll just create a new class. In this Eclipse ID, I'm going to create a new class. I'll just name this class as let's say class 6. I'll just name this class as class 6. Class 6. With main method, I'll create finish. Now inside the main method, I'm going to write the code. Inside the main method, I'm going to write the code. That is, what is the code? Okay. So I'll create an array list, guys. Okay. You can create anything, guys. It can be a array. You can create an array or array list, whatever it is. From collections, you can create array list, or from you can create an integer array. Anything is fine. Shortcut representation of the array I'll create. Let's say 9, 5, 1, 7, 8, 2, 3, 6, 4, 4. Let's say these are some elements I have given. Okay. Now in this array, I have to search. Okay. I have to search for a particular element. Okay. So what I will do is for int I is equal to 0, I less than the size of the array, ar dot length, semicolon, I plus plus. I'll iterate through all the elements in the array, guys. That's what I. And what is the target element, for example? 1 minute. For example, what is the target element? Int target is equal to, let's say, some 8. 8 is the target, let's say. Okay, 8 is the target element. Okay, I have to search for this particular target in this array. How the searching will happen? 8 will be compared with 9, equal or not? No. Then 8 will be compared with the next element, 8 equal to 5? No. 8 should be compared with 1? No, not matching. 8 compared with 7? Not matching. Then 8 compared with 8? Matching. So the iteration will end, and you'll get that something. Okay. So here what I will do here is, I'll write the logic for the same, guys. I'll compare this. I'll try to implement this linear search or sequential search, which is simple searching algorithm, right? To implement that linear search, right? Okay, to implement this linear search, I'll write the logic here. Okay, this is the logic for the linear search. Very simple one, guys. If AR of I in this array of index I, if that is 0, AR of 0 means 9, is double equal to target, then what is the thing, guys? Then return the index of the I. Okay, then return the index of the I and break the for loop. If not, here return, after all this for loop iteration is done, still this returning is not done, then return -1, guys. Okay, return -1, and the return type should be here. This is a main method, guys. Let's take this logic to other method, guys. It will be better. Public static void linear search linear search demo. Linear search demo. Here I'll pass this array, guys. Okay, as a parameter I'll pass this array, integer array or ARR, I'll say, comma target. What is the target that you have to search for in target? Okay, these two things we have to provide to this as a parameters. Okay, we have to pass them as arguments to this particular parameters, and you don't have to. Here you need to call that, guys. Okay, here you don't have to give the for loop and all. Just put all this code inside the. This method, reusable method, where replace this AR with ARR. and replace this target. I'll say T here, T for target. Okay, AR of I, return I break -1. Just will come to that. Okay. Here I created the array. Here I created the target. Now I need to simply call this method, guys. Linear search method, search demo method. I need to call. I'll call this method here. And as a arguments, I need to pass this. What is first argument? I have to pass the array. Pass the array. And second thing that I have to pass is the target. Second thing that I have to pass is the target. When I pass that, this particular method should have the return type, because return I means what is the type here? I is for int type. So return type is int. If the element is found, okay, here you don't have to write the break statement, because return will actually terminate the program there itself whenever it is occurred. When return I means it will come out of the for loop, not only for loop, but also from the method it will come out. So it's no need to write the break statement here. Return -1, okay? Either return index, if the element is found, this particular method when called will return the index of the element, or it will return -1 if the element is not found in the searching operation, okay? Now run the code and see, when I run the code, okay, so this particular method calling statement is getting this int as return type over the mouse. And here int is coming, int r for result, or int result, otherwise int result. Okay, here I'll write the logic. If result is not equal to -1, if the result is not equal to -1, then write down system.out.println, system.out.println target plus element is found in the is found. Target element is found. Okay, found at the index. Which index it is found? At the index. Target element is found at the index. This result is nothing but the index here. Okay, result. Else what you will write? Else you don't have to write the curly braces. Only one statement is that curly braces are optional, guys. You can, if you want to write, you can write it also, but they're optional here. Okay, they're optional. If only one statement is, there is no need of providing the curly braces. So I'm not writing, but let me go like this for now. System.out.println. Here I'll say target plus element is not found. Okay, -1 means not found. No need of printing any index. If it is -1 means why to print the -1 there. Okay, so this is the program, guys. Let's run this code and see. I'll improvise the program a bit more, but for now we'll go with this. 8 element is found at the target element. 8 is found at the index 4. Find it out. 0, 1, 2, 3, 4. Yes, at the fourth index 8 is there. What if I give something like 12 here? 12. Is 12 there in this particular arrays? Element in the array elements 12 is there? No. When I run the code, what will happen? 12 is not there, so -1 will be returned by this method, linear search algorithm method, and -1 not equal to -1 will become false. Else block 12 element is not found will come. Okay, instead of hard coding or manually providing the element value here, what I will try to do here is I'll just write down. Okay, here I'll write down something like this. Okay, that is, I'll write down something like this. That is here, I would like to collect this input from the target element from the user. Scanner is equal to next new scanner. Scanner is equal to new scanner. Here I will say system.in. Simply write down Control-Shift-O. Control-Shift-O. Scanner will be imported from java.util package. And here I need to help the user in entering the target. Enter any number that you want to search. Okay, enter any number that you want to search. Here int target is equal to scanner object reference dot next int I will say. Okay, using this next int I'll intake, and here I'm searching. Fine, run this code. And here scanner object, once the input is collected, right, it's a good practice to close the scanner object. Instead of giving that as to the garbage collection mechanism, you yourself are closing this object so that memory leak won't happen as part of the best practice. So right click run as Java application. Let's observe that what will happen. It will ask the user to enter any number. If the user enters any number, say 9, 9 is found at the index 0. Yes, 9 is there with the 0th index only of this array. Now run this. Let's give something like, 7. 7 element is found at the index 3. 0, 1, 2, 3. Now let's give another number. Let's give the number like 4. 4 element is found at the index 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. At the 8th index, 4th element is there. Element 4 is there. Okay. Now run this and give some element which is not there. For example, if I give 0 here, 0 is not there, right? 0 is not found. If I give any other element, let's say 99 or something, or 15 or something, okay, which is not there. 15 is not found, okay. Fine. So, hope guys you got the idea how to implement the linear search algorithm for finding the required element. So we can make this program more better. Instead of writing the code in a very simple format, use a scanner class to collect the target element from the user and search the target element either in the arrays or collections framework. Okay, anything you can search for. So in place of these arrays, you can also implement array list also if you want. Okay, if you want to implement array list, you can implement that, but some logic will change. Okay, here create one more method, public static int linear search, linear search, demo 2, I'll say, demo 2, demo 2. And here, instead of array, right, I'll collect the array list. Okay. So I'll say array list, integer, control Z, sorry, array list, integer. Here I'll say al, comma, int, target element. Okay. Here integer also you can give if you want. Okay. Int or integer, whatever it is, target element you find. And here hover the mouse on the array list and import it from java.util package. Hover the mouse on this. Return statement should be there. Return type I mentioned, right? Just put it white for now. And what is the logic? For example, here in this program, we have the array list also. Yeah, let's assume that this is a place I will write the code for the array list. I'll create an array list here. Array list, integer. You can, this is one part of the program where I have explained with the help of arrays. And another part of the program where I'm trying to find in the, here I'll write system.out.println. The separation you can say. Assume that this separation. This, you see, you can use this linear search algorithm to search for the element in the arrays or in the array list. Okay, such kind of indexing related stuff. So here I'll write a list is equal to new array list of integer, and write on the circular brackets here, put a semicolon here. Then a list dot add all. There's a method like add all method. Then you can say list dot of method. Here you give all the elements that you want to. Let's say 9. Same elements I'll provide, guys. I'll provide the same elements. Okay. Okay. Array list dot add all of what is the method add all. The type array is not applicable to the arguments. List is not for the arguments of list scanner. Okay. Okay. I'm just giving a scanner. I just wanted to copy these array elements, guys. Okay. Sorry. Okay. I'm giving the elements now. In the array list, we have all these elements added, guys. Instead of adding using add method separately, right? You can use add all method like this to add all the elements at a go. This element will be stored at the index 0, similar to arrays, guys, but it is an array list. It's a collection of objects, whereas this is a collection of primitive values. Okay. Now the same for each loop you can write. The logic will be same, guys. The same logic will be there. Logic will be same. Write down the same logic here. But here instead of array, we'll get the array list. Here array list we have to write. Here length method will not be there for collections, so size method will be there. Give the size method. Here write down al of I is equal to, okay, t al of I. Here al of I is not possible. We have to say al dot get of I, I have to say. Okay. Here array of I. Okay. Index will be like this. In collections, we have al dot get of I is equal to t. Then return I. Otherwise return the index. Otherwise return -1. Okay. Here again integer or int type you can say, no problem. Okay. The task is done using this simple modifications you have to do. You want to make it work, and you have to call this method, guys. You have to call this method. I'm also searching for the same target in the arrays and array lists. The same target I will take. Again, if you want to take another target, again, you have to use the scanner thing here. Okay. So here linear search demo method, demo 2, right? Demo 2. Okay. Put a semicolon here and pass here array list as one of the argument, and another one pass that as a target, same target. Target you pass. This particular target that you have collected from the user, you pass it. Go to the integer, and it will be upcasted automatically. Don't worry. Over the mouse, int result 2 is result 1. This is result 2. So here write down if that result 2 is not equal to -1, then write down the code system.out.println. Target element is found at the index result 2. Else you will write down target element is not found. Simple. You don't have to print the index of the array list here. Okay. Simply print out this. Now run the code and see what is happening. Two methods I created here. One of the example for arrays and another example. You can give any of this, if I give 8 here, for example, 8 is found at the index 4, 8 is found at the, I'll change the order in which the elements are stored in the array list case. So I'll pick this element somewhere. Okay. Control Z. I'll just take this element somewhere here instead of giving them here, right? Comma 9, comma. Like this, I'll give some numbers. Okay. Now let's see what will happen. Different values will get. Index will be coming different. If I write 8 here, 8 element in the array is found at the index 4. 8 element is found at the index 0 in the array. For example, 9 I'll try to find. Try to find the 9. 9 in the array is found at the index 0. Yes, in the arrays, it's the 9 is at the index 0. Whereas 9 in the array list at the index 5. Let's find it out. 0, 1, 2, 3, 4, 5. Okay, like that. If I give some number that is not available in both the things, okay, let's say give some 11. 11 element is not found, 11 element is not found. Okay, so like this, guys, you can implement this linear search algorithm. Okay, there's a linear search algorithm. I think I'm not able to make it more, lot of lines of code is there. So I think it's not possible for you to copy this. Okay. So I'll do one thing. I'll just increase the font a bit. Yeah. Now you can take the screenshot of this main method in which, creating the array, collecting the input from the user and calling the methods to perform linear search. Okay. Till here, you can take a screenshot. Hope you have taken the screenshot. Now I'll scroll down here. Okay. Now take the screenshot of other methods, reusable methods I created, which are actually containing the logic for performing the linear search. This is the linear search for performing the linear search on the elements in the array. This is performing the linear search on the elements in the array list. Okay, like the two examples I have given here. So hope that you have taken the screenshot of this one also, screenshot of the above one and screenshot of the below one, guys. Okay, hope you have taken the screenshots. So with this, I have successfully demonstrated how to write a Java program to perform linear search of a particular element in the arrays or list or collections, whatever you call. So that's all for this session, guys. Thank you. Bye bye.